Hi, my name is John, and this is for some of my students who's taking calculus. It could be AP, AB, or BC. This is the one I use. Notice that I'm using the 11th edition. I started working with this book probably about the 7th edition, 6th edition. This is the best book out there for study-wise, so make sure you use this book and when you're studying for the AP exams. So let's get started with differentiation. I can't even pronounce that. Differentiation, okay. Like I said, we're using the Barrons 11th edition. We're going to do some differentiation. We're going to use the product rule, quotient rule, power rule, and the chain rule, of course. Here's some examples. Example number 1. Let's say y equals 4x cubed minus 5x plus 7. I want to find y prime of 1 and y double prime of 1. Obviously, y prime, using the power rule, the power comes down, multiplies to that 4. 4 times 3, and then times x, and then you subtract 1, which is squared right there. And then minus 5 times x, so that second term right there. The derivative of a linear function, because we know it's linear because this is power of 1 right there. So it's going to be minus 5. And the derivative constant is 0. You can put 0, you really don't need that. So what's y prime of 1? That's 12 times 1 squared minus 5. 12 times 1 squared is 12 minus 5, which is equal to 7. There it is right there. The second one is, let's take the double derivative. 12 times 2 again. 4 times 3 is 12 times 2 is 24, x to the first, and then the derivative constant is 0, so that's your second derivative. So y double prime of 1 is equal to 24 times 1, which is equal to 24. Okay. Let's take a quick look at what we did. You're just using the power rule. The derivative constant is 1. The coefficient itself, the derivative constant is 0. One of the things I want you to notice, the derivative, here's your original function. The derivative function is usually your tangential function. If it's a rectilinear motion, then it's usually called a velocity function. The second derivative of a rectilinear motion is going to be called an acceleration function. So this is probably acceleration at the value of x equals 1, right? At the x value of 1, that's your acceleration. At the x value of 1, your derivative of your function, position function, which is the velocity function, is going to have a speed of 7 positive. Okay. Here's your second function right here. Y equals 3x plus 2 quantity to the 5th power. Of course, I want to find the derivative of that, f prime of x. So how do we find it? You take the power right here and you bring it on down, subtract 1. Inside stays the same, so it's going to be 5 times 3x plus 2. You notice that inside stays the same. The power decreases by 1. The degree is going to be 4 this time. Times the derivative of this inside. The derivative respect to x of 3x plus 2. The derivative of 3x plus 2, the derivative of 3x is going to be 3. The derivative of a constant is going to be 0. So that's times 3. We're going to multiply that. 3 times 5 is going to be 15 times 3x plus 2 to the 4th power. Okay, I'm not sure if you can see that or not. Let me just change the power setting just a little bit. This one. I think you can see it a little bit better now. Okay, so that's your derivative. The third example, y equals, square root of 3 minus x squared. I want to find dy dx. Dy dx is the same thing as f prime of x, which is the same thing as y prime. So y prime is equal to, before we do that, I'm going to rewrite this. Always rewrite your radical form in exponential form. Y is equal to 3 minus x squared to the 1/2 power. If you're not familiar with how to go from radical to exponential, get some practice on this because you're going to be doing lots of radicals to exponentials. So as soon as we take the derivative, y prime right over there, You bring down the power, subtract 1. So it's going to be 1/2 times 3 minus x squared. 3 minus x squared. 1/2 minus 1. Let's go to negative 1/2. That's negative 1/2. Times the derivative of the inside. That's the chain portion right over here. The derivative of 3 is 0. The derivative constant is minus 1. And the derivative of minus x squared is going to be minus 2x. We're going to clean this up a little bit. First of all, this goes in the, I'm going to put this like that. That way we know that this is going to be the numerator. This minus tells you it's going to be in the denominator. And so we're going to rewrite this as exponential form. The numerator is going to be, I'm going to factor out a negative right here. 1 plus 2x. And then the 2 stays in the denominator. This goes to the denominator. This becomes a square root because of this power right there. 3 minus x squared. Just a little bit tricky. Make sure you go over your pre-algebra, I'm sorry, not pre-algebra, pre-calculus information before you actually find the derivative. Okay. Let's look at this one more time. We want to find dy dx again, example number 4. Okay. So y prime, before we do that again, we have to change this into radical form. I'm going to put a 2 right here because I know it's going to be a square root. So that's a square root right there. To change this, the index goes to the denominator, and this to the power of 3 goes to the numerator. So let's rewrite it. Y is equal to 5 over quantity 1 minus x squared to the 3/2. Okay. Let's do this again. We're going to move it to numerator. That becomes 5 times 1 minus x squared. 1 minus x squared, sorry, to the 3/2 negative. So don't forget, in this type of situation, to bring it, you must bring it to the numerator before you actually start to work this out. Okay. Now, as soon as we use the power rule, we're actually taking the derivative. So y prime. So what you have to do in this situation is make sure you write every radical form, massage it into an exponential form first before you actually find the derivative. We bring it on down, so it's going to be 5 times negative 3/2 times 1 minus x squared, and then you're going to subtract 1. Negative 3/2 minus 1 is going to be negative 5/2. We like to put simplify this again. It's going to be negative 15/2, and then the negative on the exponent says we have to bring it on down to the denominator. Since we started with an exponent radical form, we have to change it to radical form again when we end. It becomes a square root. Should be a 2 right there. 2 times the square root of 1 minus x squared. That whole quantity to the 5th power. Oops, I forgot one little thing here. As soon as I take the derivative, I forgot to multiply it by the chain portion here. So I brought it on down, subtracted 1. I forgot to take the derivative of the inside, which is negative 2x. Sorry, it should have been multiplied by negative 2x right there. Notice that the 2's cancel, the negatives cancel. And so you get on the numerator 15x. Clean that up before you actually start to work on the final answer. Square root of 1 minus x squared to the 5th power. It was a little bit tricky on this one. I don't have the book in front of me. I don't even have the answers in front of me, so I'm presuming it's right, but if it's not, let me know. I'm learning too. Okay, example number 5. The function is, when they use s right over here, usually it's called rectilinear motion, okay? We talked about rectilinear motion a little bit earlier. S of t usually stands for time. So you have product of 2 functions right here. So t squared plus 1 times the quantity 1 minus t to the 2nd power. So we want to find, of course, the s prime of t, which is the derivative or the velocity function. Sometimes they call it this way, like this, v of t. Okay, s prime of t is the same thing as the velocity of time, with respect to time. Before we do this, since this is a product of two functions, this function right here times that function, I like to actually label these. That way you know what you're talking about. This is f right there, that's g right there. That's your first function, that's your second function. Something times something. So let's write it down. F is equal to t squared plus 1. G is equal to 1 minus t squared. 1 minus t quantity squared. So we have to find f prime first. The derivative of that is going to be just 2t. Bring down the power, subtract 1, the derivative constant is 0. G prime, bring the power down, 2. Inside the quantity stays the same, 1 minus t. Subtract 1, which is going to be positive 1. So the degree here was quadratic, it became a first power. Subtract 1 becomes a linear. Times the derivative of this inside is going to be negative 1. The derivative constant is 0. The derivative of negative t is negative 1. Clean that up before you actually start it. G prime is equal to negative 2, parentheses 1 minus t to the first power, if you want to put that there. So before we get started on this one, the derivative is f prime times g plus g prime times f. I know a lot of teachers, they do a little bit differently. The derivative of first times the second plus the derivative of second times the first. The reason why I do this a little bit differently is because if you want to use the quotient rule, just put a minus there divided by g squared. That way it's a little bit easier to memorize. So let's look at this. I learned it in high school to do it this way by myself. So figure it out. S prime of t is equal to the derivative of the first, f prime, which is 2t, times 1 minus t squared plus g prime, which is negative 2 times 1 minus t, times f, which is t squared plus 1. We're almost finished. So it's f prime times g, where's g? Right here, plus g prime times f. We're almost finished. You have two terms right over here. There is a common term, which is 1 minus t. So I would literally actually factor that out. A lot of teachers want you to actually factor out as much as you can. So I'm going to factor out 1 minus t. And then on the first term, I have 2t. Oh, there's also 2 right here. 2 is also common as well. So I'm going to factor out a 2 and 1 minus t. And you're left with t times 1 minus t. And then you factor out a 2 and 1 minus t. So you end up with minus quantity t squared plus 1. Let's work this out. You have to work out the inside. T minus t squared. So distribute this out and clean this up. So that becomes 2 parentheses 1 minus t times minus t squared is going to be minus 2t squared. And then plus t minus 1. I'm not sure if that's factorable or not. I really don't care. It is factorable, probably, but we're going to leave it at this stage, okay? Let me see if that's factorable or not. But don't worry about that. Even if it's factorable, I'm just going to leave it like this, okay? Because we have to go over example number 6. This function f of t is e to the 2t times sine of 3t. I want to find the derivative, which is f prime of 0. The first thing I'm going to do is label again. Let's call this big F. That way we don't confuse ourselves. Let's label this F. Let's label this G. F is equal to e to the 2t. The derivative of F is e to the u, e to any function is going to be itself. So e to the 2t times the derivative of the inside, the derivative of this right here, 2t. What's the derivative of 2t? Times 2. So f prime is equal to 2 times e to the 2t. Let's look at g is equal to sine of 3t. G prime, what's that going to be equal to? Let's move this up just a little bit. G prime is going to be the derivative of sine. It's going to be cosine of 3t. The inside stays the same. That times the derivative of this, which is the chain portion. The derivative of 3t is just 3. So I'm going to put 3 right there. Don't forget, it's f prime times g minus g plus g prime times f. So derivative of f prime is small f prime, which is 2 e to the 2t times g, which is sine of 3t plus f prime times g plus g prime, 3 cosine of 3t times f e to the 2t. We're going to clean this up just a little bit. We can only take out there's this plus right here, which means there's the first term. Second term, we can only take out e to the 2t. So that becomes e to the 2t. We took this factor out. We're left with 2 sine of 3t plus 3 cosine of 3t. And there it is. Good luck on your homework problem set. The more problems that you do, it'll actually be better for you because you actually understand things a lot more. I'm going to do some more examples, some more difficult examples, that is. Email me, text me if you have any questions. Thanks. Bye.